Hey, everybody, it's Mr. Carr. Today, we're going to be talking about 2C Day 1, writing and solving ratios and then solving proportions. Sorry, writing ratios and solving proportions. Okay, so when we look at this, a couple of things we want to make sure we are aware of. What are ratios and proportions? So we make sure we're able to write them out. And also, we have to be able to solve proportions and apply them to some real life context. So let's define these terms real quick. And even though it's in this order here, I'm going to start with ratio. Okay, a ratio is a comparison between two items. Okay, so a comparison between two items. We can write that in three ways. We can write it like this, where it is, so for example, we can do A to B. Okay, so I'm just going to use like two variables here. I can do A colon B, and I can do a fraction A over B. These are all for the ratio of A to B. Now, here's some examples. Maybe we look at the number of boys and girls in a classroom. Okay, and so let's say there are 16 boys and 18 girls in a classroom. So I could say that the ratio of boys to girls would be 16 to 18. That's an example of that. All right. Proportions are when two ratios are equivalent. Okay. And by equivalent, I mean they're equal to each other. Okay. So, for example, something like this. If I say 2/3 equals 4/6. Okay. Those are equivalent ratios. Now, we also use this to help solve, which is what we're going to get to in just a minute here. Okay. And we'll talk about what this represents in them as well. So, writing ratios. So, here's a few examples or a couple examples. A person makes 6 long distance calls and 15 local calls in 1 month. So find the ratio of long distance to local. So I want long distance first, that was 6, to local. So I could do that as 6 to 15 like that with a colon. Okay. Or I can write 6 to 15, or I can write 6/15. One thing, I'm going to kind of jump down a little bit here. One thing you always want to do is always remember to simplify your ratios. So when I look at this, 6 and 15 are both divisible by 3. So this is actually going to equal to 2/5. So even though there's 6 long distance and 15 local, the actual ratio, we would just describe it as 2/5. We would simplify it down like that. Okay. Find the ratio of long distance calls to all of the calls that were made. So this is one thing that we don't know directly from this description here. We know that there were 6 long distance and 15 local. So that means the total calls are going to be 6 plus 15 for 21 calls. So if I want to do long distance was 6. The total was 21. And then I'm going to reduce that. So I'm going to divide both of those by 3 again. So I get a ratio of 2 to 7. Okay, so that's 2 long distance calls to 7 total calls. All right, and that's another thing we can do with our ratios. Even though it's not written directly, we can do one quick step of adding these two items together to get to a total number of items. Okay, solving proportions. When we solve proportions, we're going to use what's called cross multiplication. I'm going to show real quick why this is going to work. Okay, I showed earlier, I did 2/3 is equal to 4/6. A neat pattern with this is this. If I look at the diagonal right there, 2 and 6, let's take those two and multiply them together. And let's look at the other diagonal, 3 and 4. You notice that 2 times 6 is going to give me 12. 3 times 4 is also 12. Doesn't matter what I use. So if I do another set, I'm just going to pick anything. Let's do, I don't know, 4 over, let's go 4 over 7. Okay, I'm going to pick a fraction that is equivalent to that. Okay, so everything's going to be multiplied by, let's go by 4. 3, make it a little easier. So it'll be 12 over 21. Okay, so 12 over 21 is equivalent here. And watch what happens. I'm going to do these cross multiplications. So I have 4 times 21 and then 7 times 12. 4 times 21 is going to give me 84. 7 times 12 is going to give me 84. Okay, so this is the main concept for solving our proportions here, because no matter what, if two ratios are equal to each other, then their cross multiplications are also equal to each other. So that's what I'm going to do here. I'm going to do 5 times y is equal to 3 times 10. So 5y is equal to 30. And now I just divide both sides by 5. We just use our algebra skills that we've covered recently. And I get y equal to 6. Okay. Here, to make this problem easier, I'm going to do this. 30 and 24, I can reduce. So I'm going to do that. I'm going to divide both of those by 6. And I'm going to rewrite this proportion. So 10 over x plus 3 is equal to 5 over 4. Using smaller numbers, going to be a little bit easier when I do these steps. So I'm going to have 4 times 10 on one side. And on the right side, when I do the other diagonal, 5 needs to multiply to x plus 3. I am multiplying 5 times the entire thing, x plus 3, which means I'm going to be doing distribution on the right side here. So I get 40, and that's going to be 5x plus 15 here for my distribution. And now it's a two-step equation. So I'll subtract 15 to both sides. That's going to give me 30, 25 is equal to 5x. And then I'll divide by 5 so that 5 equals x. Okay. I'm going to go ahead and clear this out. So I give myself a little space here. This one's just a little bit harder because I have the variables in 2 different spots, but it's okay. So I'm going to have 3 times b, and then 7 times b plus 6. Once again, I need to distribute here so that 3b is equal to 7b plus 42. In this scenario, I'm going to go ahead and subtract 7b to both sides. Make that a negative 4b is equal to 42. And then I'll divide by negative 4. So that b is equal to a negative, oh, that's going to be a fun fraction. Well, okay, so it's just a fraction. That'll be negative 21 over 2. Okay. And I'm okay. That's fine to get fractions as answers. So, but that's my final one. There's negative 21 over 2. All right. Last thing for today is just applying these to a few word problems. So write and solve the following equations. So I just need to read through and be careful about setting these up. So at a book sale, 6 books cost $13. At this rate, how many books could you buy for $32.50? So I'm going to look at my ratio. I'm going to actually label something for myself real quick. If I'm comparing 2 scenarios, books cost this amount, then I'm looking for another set of books and cost another amount. You can do this where you find the specific cost per book and then use that to go backwards from this $32.50, but I can just set this up as one proportion. Let's say I do books per cost. So I know 6 books are going to cost $13. Okay. On the other side here, for this to be kind of a consistent equivalent at the end, $32.50 is going to be the price for some unknown number of books. Okay. You know what? Let's use B for books. Make it a little bit more. Okay. So B is the number of books that I'm looking for. So now I can cross multiply. So I get 13b equal to 6 times 32.50. All right. Let me get my calculator handy. So I'm just going to pause it right there for a second. Okay, so I get 6 times 32.50 is going to get me 195. And then I could take that value, divide by 13. And I get the number of, so B is going to be 15. So quick context, that's 15 books. Okay, that's the number of books that you can purchase for $32.50 at the book sale there. All right. To feed your plants, you need to mix 3 tablespoons of plant food with 16 ounces of water. Before I even look at anything else, I know I'm going to be comparing. So it looks like, should have extended that, plant food to water. I could actually switch this around. It does not matter as long as I'm consistent. Okay. So for example, if I looked at this, if I flop these two and put it cost over books and I did 13/6, then this will flip to 32.50 over B. In the end, I'm still doing the same multiplications. So I'll do food over water. So we get 3 tablespoons per 16 ounces of water. If it takes 80 ounces of water, so water is going to be 80, to feed all of your plants, how many tablespoons of plant food are needed? Okay, and we'll call it F for food. All right, so now let's go ahead and do our cross multiplication. So I'm going to have 16F is equal to 3 times 80. So that's 16F is going to equal to 240. Divide both sides by 16. So the amount of food is going to be 240 divided by 16. Gives me 15. Oh, 15 again. 15. Okay. And when I look back at my question, it's tablespoons. So 15 tablespoons, which is TBSP, of plant food. Okay. And there's that context. These are word problems, so I want to answer in context is the goal. Number 8, an architect creates a scale model of a school. The actual school is 50 feet high. Oops, 50 feet high. The scale of the model to the actual school, 1 foot to 75 feet. This is, so we see that here. This is my first ratio. The scale of the model, so we got model to school. Model to school is 1 foot to 75 feet. So I can put labels on there if I want, but I'm just going to do this. I'll do 1 over 75. Okay. The actual school is 50 feet tall. So the school is 50, and we want to know the height of the model. We'll call it H for height. Okay. So now I can cross multiply that. So I've got 50 times 1 is equal to 75H. Divide both sides by 75. And I'm going to get a decimal number here. Okay. So that is going to be, you know what, we'll leave it as a fraction. Divide both of those by 25. I get 2/3 for H. Okay. And this was in feet because remember, the original one was 1 foot to 75 feet. So that means my height is 2/3 of a foot. Okay. All right. That's it for ratios and proportions. Remember, ratios are comparing 2 things. Okay. Proportions are comparing 2 ratios together. We solve proportions by doing our cross multiplication, and we're allowed to do that because equivalent fractions are equal for their cross multiplications. All right. That's it for 2C day 1. Take care, everybody.